Let's solve one very interesting problem. You must have seen this figure in the previous videos, right? And we are going to solve one of that kind of question with the help of the theorem that we learned, right? Angle opposite to equal sides are equal. So let's start with the question. Figure is given to us, right? And it's already there. In the given figure, triangle ABC is isosceles triangle. So first condition, ABC is isosceles triangle means two sides are equal, in which AB is equal to AC. So first condition we get AB is equal to AC. So AB is equal to AC, isosceles triangle. D and E are points on BC such that BE is equal to CD. So this is already given that BE, let's write another condition, BE is equal to CD, right? Means that this side is equal and up to this side, right? So what we need to prove, AD is equal to AE. So AD and AE should be proved equal. This is what we need to do that. So remember, we are going to use the congruency criteria, right? Any of that. First of all, let's talk about the conditions. We can see very well over here that we have two sides, right? Now we need to identify that which two triangles do we need to prove congruent, right? So basically let's start from what we need to prove, that we need to prove that AD is equal to AE. AD is equal to AE means this AD and AE that we need to prove congruent, equal sides. Now which two triangles are we supposed to prove congruent? That's the question. Now see, AD is present in triangle ABD and in triangle ADC, right? This two triangle it is present in, and which we are supposed to take it. Now see, that depends on us, right? And based on the condition we are going to judge. We are not going to judge randomly. You cannot take that I want to prove ABD. If you don't have sufficient conditions, you won't be able to prove triangle congruent and you won't be able to prove this result. So think wisely over here. AD. Now see, you may take triangle ADC. The reason behind that is you have AC equal, you have DC equal as well, right, to the another triangle. Same we can do over here, AE, right? We cannot take AEC. That's incorrect to do it because we don't have condition for EC, right? So for AE, I will be taking ABD. See, this BE and DC is equal and AB and AC is equal. Two sides are already given equal. Either you need to have the third side or you need to have one angle. Let's think about the angle. Based on this condition, AB is equal to AC. So let's start with that. This is what we need to, let's write to prove, right? This is what we need to prove. So let's start with this solution. First of all, let's take AB is equal to AC. AB is equal to AC. Now let's write angles opposite to equal sides are equal, right? Now when we talk about triangle ABC, let's keep triangle ABC here, and in triangle ABC, if we take AB as equal, so what is the missing alphabet? Out of ABC, C is missing. So let's write angle C. And if we talk about triangle ABC and AC, so remove AC, what's left? Angle B. So we proved that this angle and this angle is equal, right? Now let's talk about these two triangles that we want to prove equal, which is for AD, we want to prove triangle ADC congruent, and for AE, we want to prove triangle AE and B. These two triangle we want to prove congruent. Let's draw over here. Here we have triangle A, D and C, right? Somewhere near E is there. Okay. And another let's draw over here, that is Yes, something like this. Triangle A, E and B. Now see over here we have AB is equal to AC. Then we have BE. See, it's given BE is equal to DC or CD. And one more thing we proved, this triangle B is equal to this triangle C. So you can see over here SAS, side angle. Side is the condition criterion that we are going to use to prove this to triangle congruent. Now let's mention that. So let's write in the proper order. We have AB is equal to AC, that's your side. Then come to the angle. Angle C is equal to angle B, that's your angle. And one more side which is given in question, BE is equal to CD. So this is also side. So we can write by SAS criterion, triangle ADC congruent triangle AEB. That being done, but this is not what we want to prove. We want to prove AD and AE equal. So very simple. Let's write by CPCT. So here by CPCT, we can write directly that AD is equal to AE. Very simple, right? But remember, this we did with the help of this theorem that we learned. So first of all, let's start. First of all, I didn't write all the conditions that's given over here and what we need to prove. So remember, whenever side need to be proved or angle need to be proved, we need two triangles, right? To that triangle, these two sides belong to. So we prove this two triangle congruent by the SAS criterion. Now we prove this two angle with the help of this angles opposite equal. Angle opposite to equal sides are equal using that theorem, right? And basically we prove this to triangle congruent, and by CPCT we get the condition that we need to prove AD is equal to AE. So this is how we use the two conditions at a time, right? This angle opposite theorem and the criterion for congruency as well. Let's discuss one more question. Very simple it is. We need to prove here that it is isosceles triangle. Now isosceles triangle means what? Two sides are equal. So we are supposed to prove two sides are equal. Let's read the question first. We have the figure here already in the question. So in triangle ABC, AD is perpendicular bisector of BC. Okay, perpendicular bisector of BC, right? Now perpendicular means it is going to make 90 degree. Bisector means what? It is dividing BC into two equal parts, right? So let's mention over here two equal parts dash and here as well, right? So many information is given at a time. Next, show that triangle ABC is an isosceles triangle in which AB is equal to AC. We need to prove AB is equal to AC. Let's mention the given conditions here. So let's write given conditions. We have this as 90 degree perpendicular angle ADB. Angle ADB is equal to 90 degree and ADC is equal to 90 degree as well. Then one more thing, it is given bisector of BC. Bisector of BC means what? BD and DC is equal. So let's write BD is equal to CD. So these are the given conditions. And what we need to prove? We need to prove that AB is equal to AC. AB is equal to AC. Now I told you, whenever you have this kind of conditions, you always need to identify that which triangle these two sides belong to, right? So if we talk about the AB, right, AB belong to triangle ABC as well, right? And another triangle, it is ABD, right? So let's talk about that. Triangle ABD congruent. Here which triangle will be there? AC again belongs to ABC and ADC. So we are supposed to talk about this only, which is ADC. ADC, right? Or ACD, that can work out. So this is what we want to prove. So let's see, we have 5 conditions. So first of all, SSS, SAS, ASA, then AAS, and RHS, right? This is the condition. So how shall we approach? We have, see, first of all, we have angles, we have one angle and one side. So one angle and one side, it means maybe SAS, ASA or AAS. Any of three can be possible. So let's focus further. So if you observe over here, I think by this time you are very habitual that see, AD is the common side between two triangles. If I draw here, then ADC 90 degree dash here and here as well, which is A, D and B, right? 90 degree and here as well. See, AD is in both of them, right? So this is the another condition. So side, angle, side, we can say that. So what are we going to use? We are only going to use side, angle, side. So let's mention it then. So first of all, let's write about side. BD is equal to CD. That is the side. Then angle, these two angles are equal. So let's mention ADB is equal to ADC is equal to 90 degree and AD is equal to AD. So AD is equal to AD. We can write common what side it is, right? AD is the common side. So by SAS, we can write triangle ABD congruent triangle ACD, right? Now that being done, so what we want to prove, AB is equal to AC. So very simple it is, we know very well by what? CPCT. So let's mention by CPCT, we can write AB is equal to AC. Then so this is what we wanted to prove. Now if two sides are equal, then it is what kind of triangle? Very simple, right? It is isosceles triangle. So this is very easy thing to do, right? Let's recall what we did. First of all, it was given that AD is perpendicular bisector of BC. Bisector of BC it is. Don't go for this angle A, right? It is not bisector, it is not angle bisector, it is side bisector. So perpendicular, one condition there, 90 degrees. So both angles are 90 degree. Then bisector, perpendicular and bisector. So these two parts are also equal. So we have listed down all the given conditions. Afterwards, I identify that which two triangles we need to prove congruent. That's the most important part, right? Which is AB and AC over here. So we can see very well, both of them belongs to triangle ABC, right? But we are not talking about that. We want to talk about this two triangle. We can see very clearly this two. If you prove it, then by CPCT we can prove. So we proved the two triangle congruent with the help of what? SAS criterion. Then by CPCT we can write AB is equal to AC, and finally we can write that triangle ABC is what? Triangle ABC is isosceles triangle. Very simple to write, right? So this is how we prove that triangle ABC is an isosceles triangle.